Today we're going to look at our other method, which is elimination. And we're going to see kind of why it might be a little bit useful to use our elimination instead of our substitution method. So to do that, we're going to look at question 57 here, looking about Pat and his fishing competition. So Pat's fishing Pat was in a fishing competition at Lake Pisces. He caught some bass and some trout. Each bass weighed 3 pounds and each trout weighed 1 pound. Pat caught a total of 30 pounds of fish. He got 5 points in the competition for each bass, but since trout are endangered in Lake Pisces, he lost 1 point for each trout. Pat scored a total of 42 points. So the first thing we want to do is we want to write a system of equations representing the information in this problem. And for me, whenever I see system of equations, I know that I'm going to be writing more than one. So I know I've got 2 things that I've got to dial in here. So one thing that I notice here is that it says that there are some bass. He caught some bass and he caught some trout. So we don't know exactly how many there are. So right there off the bat, that tells me, hey, that's my let statement. Those are the 2 variables that we're going to be looking for. So Mr. Fortin over here doing our annotating as we're kind of working through this. So starting off with those let statements.
So I'm thinking B can be our variable for bass. They're both fish, so we'll avoid F here. So let B equal number of bass. And once again, bass just gets counted in terms of the number you count. They don't get measured in other ways in this problem. It's just number of bass we have, and then number of trout is going to be defined as the variable T. So let T equal number of trout. And that's going to help us determine how we can set up our equations here, because the number of trout and number of bass, it looks like that's going to influence how much, because each weigh a certain amount, right? So that's the number of bass and number of trout is going to influence how much in total pounds of fish he caught. And also it'll influence, because it sounds like he gets positive points for number of bass, right? 5 points in the competition for each bass, and then gets negative points, loses 1 point for each trout. So start having those variables, and then I think we can start coming up with the equations now.
Yeah, so that part right there just kind of tells us, oh yeah, these are going to be our 2. We know a total of weight, and we know a total of points. So we know we're going to have one system representing weight. We know we're going to have one system representing points. So we know that each bass is 3 pounds, each trout is 1 pound, and we know that together they combine to make 30 pounds. So that first system, we don't know how many bass, we know each of them weigh 3 pounds. So we got our 3B for our to represent that total weight of bass, plus however much trout we have. We know each trout is just 1. I'm curious about do you ever emphasize putting the 1 in front, or is it just kind of, hopefully at this point you're comfortable enough and you can move forward? Yeah.
You can do either way. It's going to look messy. This is a plus sign next to a T, so it looks kind of messy because T's look a lot like pluses. So if you wanted to be totally safe, you could drop a 1 in front of there. So I might do that right now, but T is the number of trout. If we're multiplying it by 1, that also equals the number of trout. So you can put the 1 there, you can not put the 1 there, but it could just be T. And the invisible number in front, it's got to be 1, because 1 times T equals T.
Want to come out to 30 pounds?
Yeah, there we go. Then we get our total, right? Our total's the equal part, and then we'll get 30. And we have our weight equation.
All right. And then, so systems, so we've got one more that we want to look at. And the other unit that we're kind of going by here is all about our weight. Or sorry, we just did our weight. Now it's all about those points. Because he's in a competition, he's got to score some points here. So we know that we get 5 points for each bass, but trout are endangered, so he loses 1 point for each trout. So 5 points for each bass, losing 1 point for each trout, and we know that we're going to have a total. Once again, those keywords we're trying to pick out here, total of 42 points.
So I'm actually going to start with putting equals 42 there. This is total of 42.
Yeah.
Just for me, is easier.
Yeah, absolutely. So we know that we get 5 for each bass, so we don't know how many bass we're going to have, so 5B. and we lose points. So that means we're not going to be adding on more points, but we're going to be taking away points. So we're going to be subtracting 1 point for each of those trapped. So
I'm going to leave the 1 in front of there just so this jumps out to us that we have 1t up in the first equation and then negative 1t in the second equation. And that might come in handy with part B.
Beautiful. So we've been doing a lot of work with substitution. Now we're looking at this new method. So now we're on to part B here. Is this system a good candidate for the elimination method? Why or why not, Mr. Fortin? What's your take on this?
Well, you mentioned a second ago that we've been doing a lot with substitution. Substitution is really good when we have one variable already isolated. So if we knew what B equaled in comparison to T's and numbers and all that other stuff, right? If we had B next to an equal sign, substitution is great. We don't have that in any of this here. We don't know what T would equal. And then have an expression that T would equal here. So to answer your question about elimination, I think this is a great opportunity for elimination because we have all of our variables here on the left side of the equals here. And in fact, I see 3b right above 5b, and I say positive 1t right above negative 1t. And then I have my numbers, right? I have my constants over here in the equal sign right above one another too. So I think this is great for elimination. I think that if we just wanted to see if this is a very simple one to do with elimination, we could just try to see if this is like super simple. And we can try to add the left side over here of the equal sign to this left side of the top equation and see what we get, and then add the right side of this equation to the right side of this equation here to see what we get as a resulting equation. So in the previous problems you did with elimination, we talked a little bit about this. We're allowed to add this left side to this left side here because this left side here, it equals 42. And so if we add this amount to the left side here, and we add an equal amount, right? We add 42, which is right equal to 5b minus 2, to the right side over here, we actually end up with technically a third equation that is a legal equation, right? It's just going to be simply this left side added together with this side, the sum of this and the sum of this. Because these two first equations equal to each other, the resulting third equation will be a valid equation. It will still work. So if we wanted to simply see if this is a great opportunity for elimination, we would just add them together. And what jumps out to us about that, this being a great opportunity here? What are we going to get here? Well, we get 3b plus 5b, that's 8b. And I think if you just wanted to answer the problem really quickly, right, is this a good system for candidate for elimination method? I kind of talked about that a little bit more, but kind of the biggest thing that happens when we eliminate right now is that we have a positive 1t in one equation, and then we have a negative 1t in the second equation. So when we have kind of the same amount of t's, but one is positive and one is negative, right? When we add the 1t, when we add the negative 1t, that is, to the 1t, that actually brings us to 0t. 1t minus 1t, or adding a negative 1t, equals 0. So we've eliminated one of the variables here, and we end up with this third equation here, which we know is valid because of what I said earlier, that 30 plus 42 is 72 here. So that means that 8b has got to equal 72. And yeah, I love this. What's your favorite, elimination or substitution or equal values?
Yeah, I think it all comes down to just kind of what the equations look like. And I think going back to that part B about why or why not, I think you hit on the two big reasons why this one is good for elimination that I just want to emphasize again one more time. Is one, the variables are both on the same side.
Yeah.
So we haven't set one variable equal and then we have the other one on the other side. They're both on the same side, which is nice. So that's one reason why I like it. And then number two, like you said, that coefficient between two of the same variables, they're either the same or they are opposites of each other. So they're both they're one or negative one. If they were both positive one or if they were both negative one, that to me also tells me, elimination is going to be so easy in this case because those are just going to cancel out quite easily. So
so if they're the same sides, you could subtract one from the other. That's totally legal, right? If this were a positive one right here, I would just subtract this left side and subtract this right side.
Yeah, so elimination, big fan. And I know a lot of people too are like, substitution's really easy here. I can just move the 3b over. I can just move the 5b over and everything's right there.
Equal values method.
Yeah. We've been doing all this work for it. But no, we want to, start easy, start with something that we can solve in another way easily to check ourselves. and then apply it out to harder things later on. So
cool.
elimination dead on here. So so you got eight B's.
Yeah, 8B. I'm just going to put the +0 there in case people were confused what happened to the T's again, too. So I can have it there. But yeah, we can just go ahead and solve this very quickly because I can just, really, I had the +0 there. I'm going to erase that now and then I have it. 8B equals 72. I can just divide both sides by 8 because this is just 8 times by B. I'm dividing by 8 to get rid of that 8 in front. And 72 divided by 8, does 8 go into 72? It does, nice and cleanly, goes into it 9 times. So yeah.
Process check, Mr. Fortin. Mm-hmm. What does that mean? What did all this work we just do? What does that tell us?
What does that tell us? Well, that's one of the nice things here is that we've actually defined a variable earlier on. That B was defined as the number of bass in the problem. So here, I guess this tells us that he caught 9 bass fish. And so far with A and B, it hasn't asked us kind of like really to solve a problem yet. We don't know what we're trying to find. So perhaps that's in C right here. And it says, solve this system to find how many bass and trout Pat caught. So we know here that the number of bass is going to be 9. And when we're doing these systems problems like this, we don't want to just have these random numbers here when it actually connects to a story or a context or a situation. We want to write an answer in a complete sentence. So I will do that for bass, and then we can start thinking about trout afterwards.
All right. And as you're putting that up there, just the care that we want to put into this, because with word problems, it can be hard. You get lost in a lot of the context, you forget about what you're doing, and it's always important to kind of label what we're working through so that way the audience can follow along with us, because it makes sense in our head, but we want to make sure it makes sense to the people that are looking at our paper. And so a lot of people here will just stop. I found my answer. I found my variable, but hold up, we got one more we got to do. So we know the number of bass. So what are you going to do to figure out the number of trout here?
Okay. Well, I had earlier equations here. So I knew that for instance, we had a weight equation, we had a points equation. I think the weight equation is easier to use because you don't have any negatives. We don't have to subtract it all. So anyways, I know that originally in the problem here that each bass weighed 3 pounds and each trout weighed 1 pound, and he had a total amount of 30 pounds of fish here. So I'm just going to go back to that original equation right here, this weight equation, and I'm going to move that down here. And since we know that B is going to equal 9, we're just going to replace B with 9. And we just have one unknown now. We just have that +1T. And that would have to equal 30. So now I can just solve this equation. So he had 3 pounds per bass. He caught 9 of them. So that means 27 of his 30 pounds of fish are represented through bass. And that means that the final trout, only 3 pounds of which are trout, and remember, trout just are 1 pound each. So if I'm reasoning through it in my head, that means that trout's got to be equal 3. He's got to have 3 trout caught. And let me just make sure we can solve this to verify that. And 30 minus 27 is 3. There is my second answer for my second variable, but we got to write that sentence to make it very clear why we did all this work. Pat caught 9 bass and 3 trout.
So we did all the work, and now it's time to make sure we're correct. It's a big thing, especially when it comes to systems, because there's a lot of steps, there's a lot of moving parts. And so it's really easy to make one little tiny error that causes the whole thing not to be true. So we always want to go back and we want to test this out. So the other key thing here is we want to test both equations, because we may have made a mistake when we were finding our trouts, and it would make the equation we used to find the trouts work, but it wouldn't make the other equation true. So we always want to test both of them to make sure that they are both in fact true. And what we mean by true is that the left side of the equal sign and the right side of the equal sign are going to be the same. That's what we want to verify at the end here.
Cool. So, because I think what you said there was very, very good, and I want to make sure everybody got that. We had used the weight equation to solve for the number of trout. So we know that 3, 9 is a solution to the weight equation in our system. And it sounds like what you were getting at there was that to make sure that we solve this system correctly is that 3, 9 for 3 trout and 9 bass should also be a solution to the other equation, right? It should be a common solution, right? It should work in both. So that means we already did the weight to get the number of trout. So that means I got to do the points equation to make sure my answer makes sense. We'll move this down here. I'll just move the entire equation so we can see it. And we can test out our solution right here. So 9 bass minus 3 trout. Is that going to take us to 42? And we get 45 by 5 times 9. Negative 1 times 3 is negative 3. And this looks good to go with me. 45 minus 3 is 42. So we have ourselves a solution to the second equation, the points equation.
Absolutely. So we know our work was correct here. We just kind of going back through our process here. We wrote our problem, identified the key information, wrote our systems with our let statements, so we could make sense when we found our answers, what those variables are doing. From there, used our new elimination method. We've been doing substitution, which is always great. You can do any problem using substitution. Sometimes it's going to be easier to use elimination. This is one of those cases where we want to walk through that, solve that system of equations, made sense of our answers, and then went back and checked to make sure that we did do it correctly by plugging it into both of those equations to verify our results here. So another way of solving our systems of equations we've got in the books. Mr. Fortin, very well done. And for all those out there that say, hey, I need an iPad if I'm going to be writing and doing all this stuff and using Notability. No. Mr. Fortin's doing a great job with his mouse. You can do it too.
Mouse and over.
Oh, yeah. So thanks, Mr. Fortin. We'll see you all next time.
See you later, guys. Bye. With the answer just to B right here, I'm just going to fast forward it at the very end because I didn't write it out. I don't know. Yeah. Just to reiterate, like why elimination was good here.
Yeah, see you next week.
See you next week.